Welcome to my projectbuzzer.com. Our project title is Transparently Exploiting Device Reserve Memory for Application Performance in Mobile Systems. This is our abstract. Most embedded systems require contiguous memory white spaces to be reserved for devices, which may lead to memory underutilization. Although several approaches have been proposed to address this issue, they have limitations of either inefficiency memory usage or long latency for switching the reserve memory spaces between a device and general purpose uses. Our schema on the other devices utilizes reserve memory as an eviction based file cache. It guarantees contiguous memory allocation on the devices while providing idle device memory as an additional file cache called eCache for general purpose usage. Because of eCache stores only evicted data from the in-kernel page cache, the memory efficiency is preserved and allocation time for the device is minimized. Cost-based region selection also minimized. Additionally, input-output operation be careful discarding cache data from a eCache. The additional indexing cost incurred by adding a eCache is minimized by integer index structure with the kernel page structure. The prototype is implemented on XSS smartphone and is evaluated using a popular Android applications, and the evaluation result shows that our scheme outperforms previous approaches in terms of application launches performance. The device memory reallocation time is also limited to a few milliseconds, which is sufficiently small to make our scheme transparent. In the post-PC era, a flood of mobile systems has been emerged, such as smartphones and tablets. Granted, expected that mobile phones will overtake PC as the most common web access device worldwide. The International Data Corporation also predict that the vendors will ship 1 billion smartphones in 2015. Although um, Although the computing capabilities of these systems is limited, many hardware support features complement the limited computing power of their CPUs. For example, video playback and camera features are usually implemented by separate acceleration hardware. This computing delegation from our CPUs to accelerate devices not only unburdens the CPU load but also decreases the power consumption. This is our project flow. First, we will get the get process. In this process, we will get the number of applications to be run in our application, which is being run in our device. Then the device status. First, we need to check the device status so that only we can able to run our application as needed. So that in this device status, we will be checking the total memory of the device. After checking the total memory of the device, we will be going to the process requirement. In this process requirement, we will also be checking two phases, which are individual process status and the total process status. Individual process status is also needed to run our more number of applications, and total process status is needed to check whether the device is applicable for running our applications or not. Then, if the total process status is been positive for us, then we will go to a run process. In this run process, our application will be start running. Then after running, we assume that our applications will be running in a lower memory, so that in this lower memory we will be using eviction based file cache system. After utilizing the eviction based system, the memory will be get optimized. This is our final step. This is our output. Right click the home page and click on run file. We'll be getting a home screen. Transparently exploiting device reserve memory for application performance in mobile system. This is our project title. Start. In this, we need to create number of jobs. Number of jobs will be nothing but applications which we need to get run. Before that, creating number of jobs, just view our source destination. I just use this source destination. In this, I have created a folder like jobs, which will be accessing these applications. Before creating a job, the folder has been empty. You can able to see that. Then after creating the job, I like to create a job of 24. Number of jobs be created. Job has been created. Now let's look at the folder. Jobs has been created in a. This is just like a memory where your jobs been placed and is ready to run in a queue. Then after creating the jobs, memory spaces needed will be automatically calculated and be displayed in a box. And then click on check status, because we need to check the status of the device where the application will be run. Because of checking the status, we can able to run our application in a smooth manner. This is our device status. We need to get the total memory of our system. This is our total memory of the system. And DMA. DMA is nothing but the direct memory access. We need to know about also DMA. We are checking DMA. DMA is accessing 80% of the memory, and RAM is also accessing 87% of the memory. CPU is also accessing 250. CPU's average is 500, but now it's accessing 250. Now we can able to know that our system is been accessing more memory, so that our process should be need to be in a queue. Then click on the process. This is our process requirement. We have been given 24 process, but individual process memory status is 0.95 MB, and total process status is 22.89 MB. But we don't have that memory spaces in our devices to get run, so that we need to optimize so that run application. This is our eviction file cache. You can see log files here, which has been already been run in our system, so that you can also see that there are many log files. By having this, we can't able to run our new applications, so that we need to kill some pages. Just kill some pages so that you can view that only some pages have been left here. Then also our application needs some more memory to get run, so that we use a special memory called eCache memory. eCache memory, where the remaining application will be get placed. In eCache, you can see where the remaining application get placed, where not in the kill pages. Okay. eCache memory. Then in eCache memory, we need to optimize the memory for our process to get run. In this memory optimization, available memory also we need to check. It's our available memory. DMA, our DMA person has been get reduced 52, and RAM also get reduced for 76. CPU is also 76, and our application memory is 22. You can see our files in a eCache memory. These are files in eCache memory, and these are files in cache memory. In this, we need to learn a thing that eCache memory will be get executed faster than a cache memory, because it has a direct access to the memory, so that it will be get executed in a first. By running the files, current application starts to execute. Okay. After application executes successfully, after executing our applications, our files in the memory will not automatically deallocated, because after deallocating, a new application which is been in a queue will be get allocated in our memory. You can also see this in a folder. So you can also see this in a folder where queue applications has been stopped. No, nothing has been displayed here. So our application has been executed successfully.